we have a Bitcoin protocol implementation called Bitcoin-s. So back when I got into Bitcoin back in 2013, 2014, there was one primary implementation for the JVM called Bitcoin-J, and person learning about Bitcoin, you know, I wanted to get into some project that I actually could maybe like start to understand how this like crazy currency works. You know, whenever anyone gets into Bitcoin, I think most technical people I talk to have this, you know, initial gut reaction, this is a scam or a Ponzi scheme or some pyramid scheme or whatever, another one of these, you know, 2008 financial crisis tricks that are getting played on you. So, I mean, like, I wanted to go in and like look at this stuff, and looking through Bitcoin-J was tough. And I thought I could bring some value to the ecosystem by creating this kind of robust implementation in Scala. So, talking about like the philosophy behind the development of Bitcoin-s is, I'm very influenced by this guy named Yaron Minsky, and he actually talked at SF Scala, I think, about a month ago. He's a Wall Street trader. He works for a firm called Jane Street. They use OCaml as their primary programming language, and he has these old YouTube videos on there where he talks about doing development for things that handle money. And his biggest takeaway from like working with things that directly interact with money is you should be terrified that at any moment, you know, you can like write this tight little loop to light yourself on fire and lose like, you know, a ton of money. So whenever you're doing development with things that, you know, directly interact with money, in this case, Bitcoin, you need to be careful, and you need to make sure you're taking certain procedures to hopefully, you know, be as safe as possible. So in the case of Bitcoin, it's a bearer asset. So what that just means is, you know, once you send the Bitcoin to, say, a malformed contract or a wrong address, it's gone forever. There's no way to redeem it. I mean, you can't go to the bank and say, hey, I screwed up, and give you my money back. So the stakes in Bitcoin are pretty high, and I think Scala is a good choice of a programming language to hopefully avoid those mistakes. As you guys all know, Scala is statically typed. That's a huge win in itself over some programming languages like JavaScript, which terrify the living daylights out of me for handling Bitcoin stuff. But it's also, offers things like immutability and, algebraic data types and stuff, which is very nice. So another thing that Bitcoin-s tries to do is encode invariance into the type system. So as we all know, Scala has a very expressive type system that allows you to do all sorts of cool things. But it seems like at the end of the day, it's, encoding the simple things into the type system that I've found to be some of the nicest stuff. So for instance, a Bitcoin private key needs to be 32 bytes in length. If you don't have the 32 bytes, there's something off about it, and you could possibly do something wrong with it. So, putting a little require statement inside of the private key implementation saying that, you need to follow these specific formatting rules can, be just a simple tool to make sure you don't do something wrong with your money. Another thing I've found extremely useful, and this isn't necessarily specific to Scala, but it's property-based testing. So Scala has a library called scalacheck that I use very extensively in Bitcoin-s. And the idea behind property-based testing frameworks is you can kind of specify these mathematical properties that should always hold true. So going back to the example of a private key again, an example of a property for this would be like, for every private key that I generate, they must follow this specific rule set. If it doesn't follow this specific rule set, I must be generating this wrong in some way, shape, or form. So I need to go back and look to see what the heck is going on and figure out where the bug is in my implementation. And then what's really nice about creating these properties is you can kind of build libraries of them and have them propagate up your system to deliver stronger and stronger guarantees and invariants about different layers in your system. And the end goal is to use these is to use these things to allow other people to use these things in their own testing projects. In Bitcoin-s, I want to provide a robust set of what's called generators for other application developers to use if they're building a Bitcoin application. So, for instance, say if you're building a wallet and you want to, handle all these different Bitcoin transaction types, you can use the set of generators that I've given you in the bitcoin-s library to test whatever your application functionality is, instead of having to think up all these corner test cases that are, kind of maddening to sit at your keyboard and really think about. So hopefully that's, and then there's a whole package in bitcoin-s that provides these generators. So how many people follow Bitcoin fairly closely? Fairly closely? Anybody own Bitcoin? Okay, cool. So Bitcoin is going through a political battle right now, for those that are unaware, and I naively thought when I got into cryptocurrency that it was apolitical, so that means there's no way you can bring politics into monetary policy. Then you go back and look at also the history of about every other internet protocol, and there's knockdown, drag out fights, and these not actual fights, but these long-winded battles on forums and in real life conferences, I guess in the IETF, debating parameters on a protocol. But anyway, so Bitcoin's going through one of those, and one of the features that has kind of emerged from this political fight is called segregated witness. And this is just a new feature in the protocol to make sure that we eliminate something called transaction malleability. And actually, this allows for cool things like what Fabrice is going to talk about a little bit with the Lightning Network. This wasn't possible before. Well, it wasn't easy before we had this thing called SegWit. And what SegWit does is it effectively removes this thing called transaction malleability. So people, Bitcoin's this distributed peer-to-peer network where you propagate transactions around the network. That means any node that you propagate your transaction to has an opportunity to modify it. And they can modify it in clever little ways that'll change the identifier for this. So as it's passed around the network, maybe you modify it in one way, then you modify it in another way, then the guy in the back modifies it another way. So which one's the real one? They can do this without invalidating the transaction, actually, which is frustrating for tracking features since you don't really have a canonical identifier that you can follow. It can constantly change when being passed around the network. So a group of guys smarter than me figured out how to do this and implemented it in Bitcoin Core, the C++ reference implementation, and now I've got it in bitcoin-s. So this is a really cool thing that allows a lot of layer 2 solutions to be built on top of it. So again, bitcoin-s has all these generators, which are what is used to conjure up the data for property-based testing. So for these generators, we have some crypto primitives. So that's your private key, your public key. You have scripts, which are the smart contracts that actually lock Bitcoin up on the Bitcoin blockchain. You have transactions and blocks. So I'm going to show you what some of these generators actually look like. And the very most basic generator is the private key. Yeah. So the most important thing in Bitcoin is probably the cryptographic private key that actually can be used to unlock your Bitcoins and send them somewhere. So using ScalaCheck, we've created a little generator that says, okay, anytime you call this, just create a new elliptic curve private key. And it's very simple. It's just a call to a constructor that gets some random bytes and puts them in a little case class. But using this, you can build more complex generators. So for instance, here is the public key generator. So here we're just calling flat map on the private key generator. You're getting this private key and then calling the public key method on it. So now we have generators for private and public keys. So now why not a generator for a digital signature or a double SHA 256 hash. That is the unique identifier that I was talking about earlier that Bitcoins use, or Bitcoin transactions use, as a unique identifier. So building this like little suite of libraries is relatively simple to start, but as it keeps growing, you can do very powerful things with it. So another feature offered in bitcoin-s is what is called libsecp 256k1. For any crypto nerds out there, that's an elliptic curve that Bitcoin uses. So there's different curves you can pick for various use cases in cryptography, and Bitcoin's founder, Satoshi Nakamoto, chose this curve. I mean, I think it was a relatively arbitrary choice. I don't know if he had any reasoning behind it or if it was just something he went with. But anyway, with this libsecp 256k1 is like a C library that's optimized within an inch of its life to process these Bitcoin transactions. To be able to run a Bitcoin full node, you have to validate the entire history of the blockchain. And this is extremely expensive computationally. It takes a while to actually get all this information from the blockchain, and then you need to validate every digital signature that occurs in this blockchain to make sure the transfer of ownership from one coin to another, from one person owning a coin to them sending it to another person is valid. If you don't process all these digital signatures, which it's in the millions and millions and millions of digital signatures at this point, you can't make a strong, you don't know who owns what, basically. So before we had this libsecp 256k1, it would take, I think it was like 3 or 4 days to be able to sync up a full Bitcoin node, and that reduced it down to like, I think it was like 12 hours or something at the time when it was released. In Bitcoin, we have this kind of ongoing problem though, that the ledger keeps growing and growing and growing, and I think currently it's 160 or 170 gigabytes in size. And you know, a blockchain is just a fancy append-only data structure where someone needs to keep around the entire transactional history to make sure we can figure out who owns what. Anyway, bitcoin-s supports this libsecp 256k1 functionality to be able to process these digital signatures faster and hopefully validate the entire blockchain state someday. So the next feature that I've got listed up here is types to imitate C's unsigned integers. And this is, so again, the Bitcoin protocol is written in C++. As you guys know, the JVM has signed integers, C++ has unsigned integers. So you get all these weird corner cases when you're dealing with you know, the Bitcoin protocol, because you know, 32 bits in a signed number, or what, 32 bits in an unsigned number is 31 bits in a signed number. I think I have that correct. So I decided when I started getting really into all this stuff, I was initially trying to keep all this in my head, and it was very frustrating to figure out when to do these conversions and when I needed to do these conversions. So I decided to create, you know, little types to represent these things. And they've been very, very useful for me, and I've provided, you know, like simple arithmetic operations on these types. But they could use some work too, and this is, you know, one of the reasons I'm giving this talk is, you know, a plea for, you know, people willing to write free software, you know, on this open source project. So, for instance, if you don't know much about Bitcoin but are interested in it, this would be a great place to start contributing. Is, you know, something as simple as an unsigned integer, and figuring out if there's any bugs in like this implementation, or looking through it to see if maybe we should support like overflowing to 0 or whatever, or maybe we shouldn't. Maybe we should be returning try types and code of failure if an overflow happens. It's all like, you know, I guess food for thought, and like what's the best way to have failure scenarios whenever an implementation diverges. So another thing that has been interesting here with the Bitcoin protocol lately, and the guys that maybe own a little bit of Bitcoin might have heard about this, is a new address type is coming for Bitcoin. So just like in email you have email addresses, in Bitcoin you have Bitcoin addresses. They usually start with a 1 or a 3 and then a bunch of gibberish after that, and that's just a cryptographic hash, I guess. There's been problems with the previous addresses where people will, for instance, if they're transcribing it, write it wrong, and then if that happens, they lose money forever, right? There's a pretty high stakes here if you don't write these addresses right. So the Bitcoin protocol developers decided to get together and try and come up with a new address type or address format to be able to catch some of these bugs and make sure we don't have people sending $1 million to an address that no one can ever unlock, because what's losing $1 million, right? So anyway, I've got a pull request open for this, and I'm going to show you guys a demonstration of what these things kind of look like here in a little bit. But the pull request is at this URL here, and this is an interesting thing about Bitcoin in general is there's a large demand for peer review in Bitcoin. Going back to what Yaron Minsky said is like, if anytime you're writing code, you should be terrified because you have an opportunity to lose money. Bitcoin Core has an excellent peer review process. The C++ implementation has developers that have been contributing now for 5 to 7 years, I guess in some cases, and every pull request gets reviewed by multiple people before it gets merged into the code base. And that's like what really needs to be done, because this is a huge financial application that if something wrong gets merged in, a bunch of people can lose a lot of money. Or there can even be developers with malicious intent, and you don't realize, maybe it's even obfuscated. If anyone's seen the obfuscated C contest before, people can do extremely clever things with C and C++. But peer review is really a cornerstone to any open financial system or blockchain, in my opinion. And this is another one of those. I'm going to give you guys homework or whatever. It's like, if you're interested in this stuff, take a look at this pull request. The Bitcoin stuff might be a little hard to understand at first, but you got to start somewhere, or you got to kind of crawl before you can walk. And they always say with Bitcoin or anything else in life, the best time to start was 6 years ago, and then the next best time is to start today, right? So, yeah, let's check out some examples of Bitcoin-s, and we will open up our friendly. Okay, can you guys see in the back? Is this large enough? You? Good? Okay. We're gonna import a few things to start. So this is kind of where the entire Bitcoin-s core project resides. And we are gonna import the crypto package. So let's start with the basics. Let's create a new private key. Okay, so this is, exactly as it looks. This long hex string here with a Boolean at the end, I guess, is a 256-bit private key that would be stored in a Bitcoin wallet. So these private keys are used to secure ownership on the Bitcoin network. And as you can see with Bitcoin-s, you just have this little constructor here. You call to generate this new private key. Is everyone with me so far? Good? Okay. Now, the next thing, to receive a Bitcoin payment, you need to be able to derive the public key associated with that private key. So underneath the hood here, there's some fancy math happening, and there's a crypto library that I call. But we will just call the simple public key method. So again, we generate the public key there. So this is when the Bitcoin protocol started, Satoshi only had one contract type. And that contract type was called pay to pub key. So to receive a payment from somebody else, you would just send them this big old hexadecimal string here. And then your counterparty would actually create a contract and send you this public key. So we can actually look at what this contract would look like. So the big buzz is like smart contracts or whatever. There's one of the buzzwords in the crypto space anyway. I think they might be a little misleading. I think of them more like dumb contracts because you can actually execute them on a computer. Computers aren't really that smart. They do exactly what you tell them to do. Smart contracts are like, you get all these ambiguities, like legal contracts, and you take them to court. The judge has got to figure out what's going on. These are, dead simple contracts that a computer can execute. So we'll call this pay to pub key. Okay, cool. So what is in this string here? It's a contract that is encoded in hexadecimal. So Bitcoin inside of it has a little programming language that you're going to run these instructions against to figure out if the right person signed this transaction. So I'll print out what these instructions look like. Okay, so this is what you need to get this program right here to evaluate to true to be able to send Bitcoins from one address to the other address. I'm going to give you a little bit of details on what this program actually says. So with the Bitcoin contracting language, you need to, it's kind of similar to like assembly languages if you've ever used those before. I think the real definition is it's like a Forth-like language, which I'm not familiar with Forth, but I mean, that's, I guess, what it is. So the very first instruction here is specifying how many of the next bytes to push onto the stack. So this the shared state in this program execution is the stack. So anything you need to do, or any variable you need to store, needs to go onto the stack for you to pop off later and have an opcode use it. So the very first thing is push 33 bytes onto the stack. These next 33 bytes here is this public key that I derived from my private key earlier. So this public key will be pushed onto the stack. And then the final operation here is op-check sig. And this is one of the heavy lifters in the Bitcoin protocol that says you need to check that this transaction is signed by the private key that mathematically corresponds to this public key. So this is how you get these ownership properties in Bitcoin. So this is one of the oldest contract types that Satoshi eventually began with. I kind of have nice little helper functions to be able to translate it to more of a human readable form, because this nasty hex definition at the top doesn't really tell anybody anything. So this actually has gone out of style, though. No one uses pay to pub key anymore because you can't derive an actual Bitcoin address from it. Actually, I don't know. Do you know why they never specified an address format for pay to pub key? Because I just know we don't anymore.
Because it was replaced very quickly by pay to pub key.
Yes. Segue. So it's not. This never was used widely outside of the very beginning people in Bitcoin, because it was very hard to exchange this public key. And if this public key is embedded in the blockchain for the entirety, it's basically embedded in the blockchain right away. So actually, quantum computers could possibly break the discrete logarithm problem, it's called, which is kind of the problem that makes cryptography really hard, and reverse engineer the private key. So I think that might have been one of the big reasons they didn't go with this contract format. So they created a new contract format called pay to pub key hash. So I'm going to create a new script pub key, pass in the pub key from before that corresponds to the private key I first generated. And now I get this long, nasty hex string. And we'll print out the instructions for it. So here is the contract that still corresponds to that exact, you still need to provide, so you still need to sign the transaction with a private key that corresponds to that public key we had before. But there's a few other things you need to satisfy. And namely, you need to provide something on the stack that hashes to this value right here. So a way that the protocol developers figured out to get around this problem of quantum computing possibly having a big breakthrough and like everyone's bitcoins can be stolen right away was hashing that public key and saying, okay, when you want to spend these bitcoins, A, you need to provide the public key that hashes to this value here, and then B, you need to sign the transaction with the private key that corresponds to that public key. So this is in the Bitcoin contracting language is how you go about achieving this. You duplicate what's on the stack top. You hash that stack top value that you just duplicated. You check to see here with this op equal verify if the two things on the stack are equal. If that's true, then you check the signature on the transaction to see if it was signed with that public key. So a lot of steps there, and this is why some people have gripes about Bitcoin's contracting language. They'll say there's other programming languages that have simpler, more traditional programming idioms. So like for loops or while loops or syntax that doesn't look like this. But it's done this way for good reason, and you need to be careful what you can allow in your smart contracts too. I mean, we're all programmers here. I mean, how many of you have written bugs before? It's super easy. With a project that is a competitor to Bitcoin, like Ethereum, I mean, there's already been multiple instances of people writing smart contracts and having them hacked for 30, 40 million bucks. This is, the dual-edged sword with, these contracts is you're writing a program that if you can get this program to evaluate to true, you can send money wherever you want. So you have to be very, very cautious with doing this. So now we have this pay-to-pub key hash contract. And now let's encode this into a Bitcoin address that some of you have seen before. So using Bitcoin-s, we're going to import a couple things. Now we're going to create a value called pay-to-pub key hash adder and call the constructor. And we'll have to specify the network that this goes on. So some people don't know this, but Bitcoin has multiple networks. There's mainnet, which is the one we've all heard of before, that has like $100 billion worth of value on it. But then there's a test net that developers use to tinker around. That's where you can really have fun. I'm going to specify the mainnet as the parameter in this address.
Why do you have to specify the net?
Because I will show you. It's nothing to do with the actual contracts itself. It's for humans. So if we drive... Yes. So in this case, you notice how you have the 1 on front, which is if you've ever received Bitcoin for payment before, you'll see usually they have a 1 on the front. Now, if I were to change this to testnet and done. See, now this one starts with an M. So that's like an easy way if you're a human, you're like, I don't want to actually send money, real money if I'm tinkering with my application or whatever. So now you can like send this over to your friend and do some crazy contract that maybe will lose you money. So yeah. Now, again, I was talking about Bitcoin. These address types have problems. Namely, there's kind of weird characters in them. There's mixed case. So say if I'm talking to you and I'm trying to relay what an address you need to pay me at is, I need to be like, it's lowercase m, lowercase r, capital case W, lowercase v, you know, blah, blah, blah. It's super easy to mix one of these up. So one of the features that these new address types have is like they're all the same case. But to be able to illustrate this, and this is another powerful contracting thing that was added with segregated witness is versioning of these contracts. So in this old system I was showing you here, there's no way to version them. It's just, you know, this is the smart contracting language, so, you know, that's the way it's going to be. And doing what we call hard forks, which is a backward incompatible change to Bitcoin, is very controversial. Again, we're sharing in a $100 billion currency here, and you can imagine getting everybody to agree on, like, you know, what the color of the carpet is hard enough rather than changing rules in a $100 billion currency. So we try to avoid, or actually Bitcoin almost has avoided hard forks altogether. But the Bitcoin developers figured out a clever way to create a versioning system for this smart contracting language that I was talking about. So we can, you know, maybe we find some cool new cryptography that we want to use, and that's a lot of what this conference I was at this weekend was talking about. We have to have an upgrade path to, you know, say something breaks too. Like maybe the cryptographic algorithm that Bitcoin uses currently is out of date because computers got super powerful, or the discrete logarithm problem that I was talking about earlier broke. We need a way to upgrade. And so I'm going to show you what these new contract types look like. So we have these new things called witness script pub keys. And there's just a new format of these contracts. And we're going to pass in this pay to pub key hash contract to this. And we again get one of these long nasty hex strings. But let's print out what the actual instructions look like. So again, this looks a lot like the very first one I showed you guys. But the most important thing here is this op0. And what this means is this is a witness version 0. This is the, you know, first version of these contracts. So whenever we figure out something new, we can upgrade and be like, okay, you know, now we're talking about version 1, and we can use this cool new cryptographic algorithm or some crazy new smart contracting feature that's hopefully safe. But then, you know, it checks the witness version and then pushes this hash onto the stack. And then the next thing that means the program that's nested inside of this must, when hashed, evaluate to this exact same hash here. And then execution continues like before. And I'll show you guys what the new address type looks like. So this is a little bit of a preview. The Bitcoin protocol is going to be upgrading to this 0.15.2, I think is what it is, within a couple months, I think is when they're rolling that out, at least in Bitcoin Core. So this is what the new address types will look like when they come out. And you notice here we have this separator value 1. So everything on the left-hand side of 1 signifies what the network is. And then everything on the right-hand side of the 1 signifies what the actual witness program is. And then if we were to replace that with testnet, we got a TB here that signifies. And then actually when Fabrice gets up here, I don't know if you have any examples, but Lightning Network, the layer above Bitcoin, has their own address scheme. So this new address scheme is like pretty flexible too, which is really cool that we can build layer 2 stuff with it and do all sorts of crazy things. Okay, let's get back on track. So the future, I mean, I've already pleaded with you guys to, throw me a pull request or some code review. But where I want Bitcoin-S to go in the future is we currently don't have any native wallet support. So that means storing private keys, storing smart contracts that you need to spend coins, and then an easy transaction builder type. So that's, to build a transaction right now in this library, it's involved, we'll say. There's no way you can expect third-party developers to get that involved into it, and actually it might be a little unsafe for them to do it. So a nice way to, say, spend coins to this address, sign it with this key, maybe use this subset of coins to fund this transaction, and then maybe do a sanity check at the end to make sure you're not sending an absurd amount of money somewhere. So another thing is an SPV node. So what SPV means is simple payment verification, and that is a lightweight way to process Bitcoin payments. So a full node is when you process every single transaction on the blockchain, and you can't do that on your smartphone, right? It's just not practical. You need a lot of, you need a beefy computer to be able to do it without it taking forever. So what an SPV node does is it uses cryptography in a clever way to check if a transaction was included in a block. And then you're making an assumption that if that transaction was included in a block, the miner must have thought it was valid. So another way of saying that is you're trusting the miner that they did transaction verification for you, which is a little bit against the ethos of Bitcoin, because everyone should verify their own transactions, but then there's the practical side of it too. And then maybe roll that out to a full node eventually, but writing a full node in a different programming language can be dangerous. There is always going to be discrepancies between a code base written in one language and a code base written in another language. There's, implementations of various different internet protocols, like say HTTP, SMTP, they all have their own different implementations, but in this case we have, again, money at stake. And the key innovation behind any blockchain is converging on who owns what. So that means if I have a Scala implementation that thinks transactions are valid under these certain certain cases, while the C++ implementation thinks it's valid under a different set of circumstances, you have divergence of the ledger. You have divergence of who owns what, which can be dangerous, because that means you could accept a payment that a bunch of the rest of the network doesn't think is valid. So that means you really haven't accepted a payment. But your node thinks you do, which is a really bad thing. It's like someone handing you $100 that you think's real, and everybody else looking around is like, that's fake money. So again, there's questions about it, and maybe it would be interesting to do, but you have to caveat that with the risks around it. So an RPC client, and what this RPC client would do is stand in between Bitcoin D and any Scala application built on top of it, and call the C++ implementation, get the message back, relay it, and convert it into native Scala types, and then your application can do whatever you want with it. And then, the biggest thing with Bitcoin-S right now is keeping up with Bitcoin R&D. It is moving at a breakneck pace, people, and I don't think it's going to stop anytime soon with the latest conference I've been at. There's a lot of interesting stuff on the horizon, and it's an exciting future. But as someone that's developing it, you got to make sure you have support for all these cool features, or else no one's going to use them at the end of the day, right? So I think I'm gonna. Oh yeah. So where can you contribute? Again, another shameless plug. I'm not shilling enough for Bitcoin-S. Anyway, so I have some issues on like the Bitcoin-S core repository, and what I wanted to kind of try and do is like link issues to you guys that aren't Bitcoin related, but they're Scala related. So you don't necessarily have to be a Bitcoin expert to go through some of these issues. You just need to know the Scala programming language. And hopefully once you dip your toes in the water, you can like get comfortable. Like this is even what I did when I learned Bitcoin originally. Was like you start this little subset that you're really comfortable with, and then you move out a little bit further when you get comfortable with that, and then you keep going and keep going and keep going, and that's how you learn anything, in my opinion. So like I've got some issues on this issue tracker that they're not Scala. I mean, they're not Bitcoin related. They're just me being a terrible Scala programmer, or not doing things the right way. So there's some things on there that you can kind of dive into. And hey guys, thanks for having me. I really appreciate you guys taking the time to listen to me talk about this project, and it's something I'm very passionate about. And I think Bitcoin has come a long way in just the time I've been involved in it. And there's people that keep on coming up with brilliant new use cases for it. And it really is this like kind of unexplored frontier, in my opinion. Here is my Twitter handle up at the top here, my email, and then again the bitcoin-s repository for you to send all your pull requests to. I can see some people already have one typed up, right? But yeah, thanks guys, I really appreciate it.